Hi students, welcome to my lectures on chemical reaction engineering. In today's class, we are going to discuss about the reactors in series. That means I have two reactors, example continuous stirrer tank reactor and PFR. Among these reactors, which one I have to keep first and which one I have to keep second? That means what is the best possible arrangement? What is the best I can get? That means if I keep CSTR at first and PFR at the next, or PFR at first or CSTR at the next. So that is called the best possible situation. So let us define the best arrangement. The best arrangement is that in whichever arrangement we get overall volume less, that is the best arrangement. If I keep CSTR at first, PFR in second, if I get a overall volume less, then that is the best arrangement. If I keep PFR at the first, CSTR at the next, if I get the minimum volume, that means the best possible arrangement is that. That means let us define the overall bestness is in whichever may be the arrangement, wherever I get a less volume, overall volume, then that is the best arrangement. Overall volume nothing but CSTR volume plus PFR volume is called the overall volume. If I get the overall volume less in whichever may be the arrangement, that is the best arrangement. So example, if I keep CSTR at first and PFR at the next, the overall volume is volume of the CSTR plus volume of the PFR. And the other case is if I keep PFR at the first and CSTR at the next, the overall volume is the same, then volume of the PFR is equal to plus volume of the CSTR is my overall volume. So not every time by keeping CSTR at the first I get the minimum volume, it is not like that. It is not the case every time if I keep PFR at the first I get a minimum volume, that is also not the case. It depends upon the curves, okay, convex and concave curves. Okay, you can see two different kind of curves I have drawn. Let us see for these two different curves which arrangement is the best arrangement. Let us take the first case example, concave or concave curve. That means Fa0 by minus Ra into x. I have this kind of nature, concave nature, right? The plot, these are the these are the circles or the data points. If you have this data with you, then let us, which one will be the best? Okay, wherever the curve is changing, its slope, you can see it has a positive slope and then it have a negative slope, then it have a positive slope. Fix up that point, okay, wherever it is changing the nature of the curve. So you draw a vertical line and define a conversion which is x1. That means 0 to at this minimum point which is x1, x1 to x2, this is the maximum point, okay, this is your range, 0 to x1, x1 to x2, okay, because there the curve is changing its nature. So let us, between 0 to x1, which one gives the less volume? Example 0 to x1, I have defined the area A1 is that means wherever you have drawn a vertical line, draw a horizontal line. So the area inside this box is A1, the area outside the box, that is under the curve, is A2. You know A1 is less than A1 plus A2. If you remember, what is the A1 area? Area of this rectangle is nothing but the CSTR volume, and which is less than A1 plus A2. A1 plus A2 are the area under the curve which is called the PFR area. That means till conversion x1, if I keep CSTR, then that gives my less volume. What happens to my x1 to x2? Then at x2, that means up at final conversion x2, plot a straight line wherever it touches the curve and draw a horizontal line till x1. Why till x1? Because we have already defined till x1 CSTR is the minimum volume. we are taking now x1 to x2, which one is the less volume we are finding out. So from x2 always comes from back to front, remember this. That means x2 draw a straight line, then wherever it touches the curve, draw a horizontal line till x2, and again it dropped another line. Now imagine second, for conversion x1 to x2, A3, the area under the curve, less than A3 plus A4. A3 plus A4 is my rectangle. Okay, that means A3 is under the curve is nothing but volume of the PFR is less than the volume of the CSTR. That means A3 less than A3 plus A4. That means for the conversion x1 to x2, PFR is the best because PFR is giving less volume. That means for the initial conversion, you keep CSTR. That means you get with less volume of the reactor itself, you can get a good conversion. From x1 to x2, if you keep PFR, that means small PFR is enough to reach conversion from x1 to x2. So the best possible arrangement is first is CSTR, next is PFR. That means the case 1 is the best arrangement for this kind of curve. Let us take the convex curve. If you have the curve of this nature, FA0 by minus RA versus X, wherever the curve is changing its nature, it is a positive and this is a negative slopes. Okay? Wherever it is changing the nature, mark that point, draw a vertical line. Then name 0 to x1, x1 to x2, the remaining curve. Then let us define for 0 to x, between the conversion 0 to x1, which one gives the less volume? And from conversion 0 to x1, area 1, that means area under the curve is less than A1 plus A2. That means area 1 is nothing but the area under the curve, that means it is a PFR. Area under the curve means PFR. PFR volume is less than the CSTR volume. That means up to conversion x1, if you keep PFR, that means you can get the product within less volume reactor. Okay? From x1 to x2, if you see, for x2, draw a straight line. Wherever it touches the curve, draw a horizontal line till x1 and drop a vertical line. Okay? Now let us see. For the conversion x1 to x2, that means x1 to x2, A3, that means the box area is less than the area under the curve. The box area is A3, area under this curve is A4 plus and A3, everything is under area under the curve. That means A3 is nothing but volume of the CSTR, which is less than the volume of PFR. That means the best arrangement is up to certain conversion from 0 to x1, use PFR. From conversion x1 to x2, use volume of the x1 to x2, if you can use CSTR. That means what is the best possible arrangement? First you use plug flow reactor followed by CSTR reactor. Okay, this is how you can able to define the best arrangement for to get the minimum overall volume. What was the objective? In whichever may be the arrangement, you get the less volume, that is a best possible arrangement. If you do the other way, then the things will be different. Okay, imagine if you keep here the volume of the CSTR is the minimum volume, so we are keeping CSTR at the first. If you keep PFR at the first, what happen? You need bigger reactor. That means you need to spend too much amount of money by constructing the bigger reactors. So that is where overall volume should be minimized. I hope you understand the lecture. Let us meet with the new lecture.